Dirty Scrap Podcast.
First of all, Judy, thank you so much for being here with us in Dirty Scrap Podcast, the podcast that use and we dive into the cutting edge technology that is breaking out sustainable processes and practice to the aluminum recycling industry. And today, as I just said, we are here with Judith Jenny. Is that the right way to pronounce your name?
Yes, Judith Jenny. Yeah, absolutely. So thank you.
So you are the managing director of Austin AI Europe. That is a company that is focusing on sorting and cleaning and different type of approaches using AI to make these practices better and to help the sustainable point of view on the aluminum recycling. How are you?
So I'm fine, thank you so much. Especially at the very beginning of a new year, we are full with hopes and new challenges. And the good point is that we closed a very special year in 2024. We were successful with our LIBS sensor sorter, sold 4 units all over the world. So we are very excited about the coming year with even oversize our successes from 2024.
Great. So 2025 looks like it's going to be a great year for you and your company, and I'm happy to hear that. Now, we will talk about the Austin AI sorting technology and AI LIBS technology, but before we dive into that direction, I want to get to know you a little bit more. You have an impressive background. I know that you have a PhD, and also I know that you've been in different companies, as managing director and founder of Green Lab, and, different approaches from the investigation point of view, and now you are the managing director of Us AI. I want to get to know you a little bit more and your background and how you get involved into this industry. So if you can give me a little bit of more information. Are you located in Budapest right now?
Yes, absolutely. So Austin AI Europe is established in Hungary, in the capital city is Budapest. So we are in located in Budapest, absolutely. So thank you very much introducing. You know a lot about me already, but a few words about myself. So all my life is about chemistry. I loved it from my primary school, maybe because I had very good teachers all in my life. So, and graduated as chemical engineer. I also had 10 years in academic research on analytical chemistry. And then after, when I established my first company, as you mentioned, that was Green Lab. So we were distributing chemistry-based instruments for different environmental applications like air monitoring and waste identification and also water analysis. So that company is still running, though I switched to Austin AI Europe. But back to that time, so in the early 2000s, so that was when first time at a scrapyard. And the reason was that we were also distributing the very first X-ray tube based handheld XRF analyzers. So they are, the XRF is a more historical technique, chemical spectroscopy based technique, which is an ideal tool for different alloy identification. So we like that instruments very much, and we sold a lot on different scrapyards. But the XRF is mainly dedicated for the heavy. So in the aluminum industry, a new technology that we are talking about today is the LIBS is more advantageous. So in 2021, I switched from my previous company to Austin AI Europe, and I established this company. I'm the owner of it, and we are dealing with the Austin AI US developed and patented. It has a worldwide patent with this LIBS sensor sorter. And we are responsible for not just for Hungary, but all other countries except the American continent. So this is a few words about myself.
Right. So what you're saying is just at the beginning of the 2000, you get involved to the scrap jars with your technology in order to help the scrap jars to sort the different type of alloy you have. I am familiar with this technology since I was in school because I'm a material engineer. So obviously, as a material engineer, we went through a lot of different labs, study, and everything, you know. And for me, it's very interesting how this technology is getting more and more important in this industry because I think it's helping the industry to understand very well how to be more efficient and more sustainable. Saying that, 2000 early 2000, so 20, 23, 24 years ago, when you started using this technology or offering this technology to the scrap jars, how was that technology at that time and what is different right now that makes this technology like moving a step forward than the technology that you used to be or we used to use in the past? So what is the difference right now?
So back to that time, the XRF technology which is really a chemistry-based technology used for the different alloy sorting. And if it just the handheld, you cannot achieve a high throughput, you know. So you are just on site, testing one piece to the other, walking around with the gun. But the industry always needed more, always needed high throughput system. So that's why it was a good point when I started working with the Austin AI designed XRF-based process system. So these are providing still a very precise sorting for the users, but on a 4, 5, 6 ton per hour throughput, even higher. Of course, later on we can discuss about what the throughput is depending on, but the process technology always helped a lot of the industrial application. So back to that 20 years ago, approximately, only XRF existed for the metal scrap sorting plant. And because it is rather for the heavy metals, there is a need, or there came up a need for the light metals precise analysis with the high throughput. And that is the LIBS. The difference between XRF and LIBS, that XRF both are emission type spectroscopy with elemental analysis, but XRF is based on X-ray excitation, while laser, LIBS is a laser-based technology. So it's more safe in the recent time. So X-ray is a little bit status, but LIBS has its advantage beside the analytical characteristics, has its advantage that its safety regulation is rather big. So, but the key point of the LIBS is the light metal analysis. It's rather useful for the light metal analysis, especially we are talking about aluminium scrap sorting. So in aluminium alloys, the silicon and the magnesium are key alloying elements. So the LIBS can determine these sort of elements more precisely than XRF and can go down more lower detection limits than the XRF. So if you are really involved in aluminum recycling, you have to use the LIBS.
Right.
And
let's talk about the rate. What is the lower rate that this LIBS technology can go, for example, comparing to the, because as you just said, X-ray is a good technology, been in the market for a long time, right? And it's accurate. It's not as accurate as the laser system on the LIBS, and I understand that. But also it's not safe, or it's not that safe because it's X-rays a day, right? So I think LIBS is clearly more safe and is more accurate, but what are those limits you can reach with the LIBS technology against the X?
The LIBS technology is rather precise on the light element fractions. It's a low atomic number elements like silicon, magnesium, lithium, which is coming up in the aluminium alloy type. So and the lighter and lighter elements are required, or lighter and lighter metals are required in the automobile industry, also in the aerospace. So these elements are better seen with the LIBS technology. achieving lower detection limits. So for the magnesium, for example, we can see 0.2, 0.3% in the entire alloy composition, and the similar with the silicon as well. So with XRF, we can only go higher, so 0.5, 0.6, a little bit higher with the detection limits, not really achievable any lower than 0.6 or 7 with these elements. So on the other hand, the manganese and the copper thing can also be seen with the wear composition, especially with our LIBS, which I believe it's a very powerful and has a very specific analytical performance compared to other.
Right. From the scientific point of view, because I think everyone in the industry is getting used to, listen about LIBS, but I think no one understands very well how this technology works, because behind scenes, a complete scientific world is right there, right? Because we are using a spectrum of every alloy to understand the alloy. So can you explain us a little bit more detail about this, how this technology works?
So we excite on the chemistry based, we have a sort of excitation of the spot of the pieces. And if someone is familiar, and I believe you are among those who were involved in the aluminum industry and are involved in the aluminum industry, the standard method for testing aluminum alloys on the laboratory scale is the arc spark. So it's a standard method, so very precise, you can achieve. But the arc spark spectroscopy needs an excitation on a very high energy scale. So it is not possible to implement into the high throughput industrial scale or also in a lower type. So we excite the point of the samples and generate a plasma with the laser source, and then we can have elemental spectra and emission spectra, and you can have dedicated elemental lines, which are characteristic lines of the dedicated element. So you have a whole spectrum and you can analyze it with a very high precision. So the recent time when the solid state fiber lasers are already available on the market, that have the entire LIBS industry to have and design industrial scale LIBS machine, and it's mostly used for aluminum, magnesium, and other light metals industry as well.
Right. So what we are seeing in this LIBS technology is we are sending a energy beam to the material. So we excite the material, and the material will release some energy as well that allowed us to understand what is this material so we can sort the material very, very accurate, right?
Absolutely, because the resolution of at least our LIBS module is very good. So it's within nanometer ranges, very low nanometer ranges. So you can see a differentiation between elements on a very, very precise way.
Right. I mean, yes, this is an amazing technology. Now, let's dig into the technology itself, your technology, how this technology been involved into the industry, and how your technology is different from other technologies that we can reach outside. Then after this, I want you to develop about your technology, about the capabilities of your technology, how the technology being useful into the. So if you can share a little bit more about how your technology is different from other technology, and also I want to understand very well how you guys are using the AI, because for me this is a big jump, right? I can see that a lot of different industries are using AI in so many different places and so many different activities, but aluminum industry is a little bit behind. And I think this step that you are making is a huge, huge step for the aluminum industry. So can you elaborate a little bit more about your technology and how this technology, modern technology?
So first of all, our AI means automation and instrumentation. So it's not the artificial intelligence.
Oh, okay, my bad. Okay, that's fine.
That's a key point. And but we are planning to put more and more artificial intelligence in the entire process as well. And there are many, many important steps where AI as artificial intelligence can be used. So in our LIBS sensor sorter technique, we are not using so much of artificial intelligence yet. So we have real feeding and real sample recognition. Mm-hmm. I will tell you a little bit about it later. So our design of the LIBS sensor sorter, and as you said, it's really more and more LIBS sensor sorter are coming to the market, but right. Still not a lot. Just 4 or 5 different models are existing, or different manufacturers are going with that technology. Yes. The key difference of the 4 others compared to ours, that we are not using the bell type feedings. So what we are using is a so-called shoot type design. If anyone is interested in more details, we have a very short video on the YouTube. Maybe later on we can watch it together. But one key point is this shoot time design and the shoot from below laser arrangement. Mm-hmm. So together with the shoot type and the feeders, what we are having, the vibratory feeders, we can provide a singular distribution of the sample on the feeder, even at higher than 4 or 5 tons per hour throughput. So mm-hmm. Our pieces are singular when they achieve the laser. It is due to the vibratory feeders on one side, and on the other side is the free fall design. When they achieve the top of the chute, they fall down, and if there are a few pieces might be overlapping each other, due to the free fall, they still became separated from each other and they fall into the laser path one by one. So that's why we can say that we analyze each single piece by the laser. When they hit the laser, so we get the analytical results, the spectra, what we already discussed before, and we can judge each piece if compares or comply with the set composition, what right. we require to act the mix, or not. So our system works on a binary basis, yes or no, of course, fulfills the criteria. And since this arrangement, we believe that we can achieve the highest purity on the market. So because each single piece is analyzed by the system. It is on one hand. The other hand is, which believe is very unique to our system, is the high analytical performance of the module. So as mentioned before, we can go down to 0.1% of the concentrate, very freely configurable configuration. You can configure a criteria only with one element. For example, we often use it when sorting and separating wrought and cast metals or wrought and cast aluminiums. So it's just one concentration like silicon, for example. But if you want to go to the very specific aluminum alloy type, either 5052 or 1100, or 8012, for example. So you can set 6 elements with dedicated concentration, and then we can sort and extract this sort of alloy type from the entire mix. We believe that with our pioneering position, Austin AI was the very first who entered into the market with technology, and I can mention that this technology was patented by Austin AI and Hydro Aluminium together. So it's a joint patent. Okay. And Hydro Aluminium is also using this sort of technology on the plant. So that's a good advantage. And I believe that since the very first presence of the Austin AI LIBS on the market, which was around 2016, so we achieved the highest number of the sold unit on the market. So we would like to keep this pioneering and advantageous position market, even though that more and more LIBS are getting on the market. But the importance of the LIBS is seen because of the more and more models available here.
Right. So as far as I understand, so your technology is a little bit different, not just because of the technology, but also on the design of your equipment that you are allowed to check every piece of scrap that is going into your system so you can have a better and more accurate sorting process. But also you have the capability to, let's say, set up the system in so many different ways that you can really be very accurate to what you are looking for into the sorting process, right? Is
Absolutely.
hydro
So
Okay, go ahead. Yes.
yeah, no. So this is also unique. We are not just able to sort 5,000 group or 6,000 group or maybe 3,000 group. We can go to subclasses, or any non-existing composition can be set in our system. For example, if a smelter wants just aluminum fractions with low
Right.
manganese, no any other element, so we can set just that. And with this design, we believe that we really provide ready to melt scrap, which of course helps the foundries to save energy, not needing further blending or through this. So they also, of course, save more foundry and turning time. So, and it's of course the energy saving as well. We
This is
call
very
it ready
interesting.
to melt.
Yeah, this is
But
very interesting,
ready
the
to
ready
melt,
to melt, because
yeah.
as far as I've been working in this industry for, I've been in this industry for almost 8.5 years here in the US. And more, I am seeing that we need to close the gap between the scrapyard and the foundry, because as far as we are not understanding that we can improve our sustainability and our efficiency, we are not doing that. So what you're saying is, for me, I think is the bridge that we need between one industry and the other to make a complete recycling industry, to build them together. Now, hydro has something to do with your development of this technology, or they just are using the technology and you partner up because they were the first company to use your technology? How was the partner up?
They are using this patent, and they also were building their own design or
Okay.
system. So use this design, and they are implementing this sort of sensor sorter with the shoot type and with the shoot from below on their own plant. So it's just started a few years ago.
Right.
But
So I understand also that you can sort tweed, sorba, and so many different type of scrap, not just the clean scrap that we have from the extrusion scrap or 7,000 series, 6,000, 5,000, 3,000, but also this very dirty and complicated scrap like a tuition sorba that more people is trying to get this material into their process, because at the end what we will see in the 2025 is more aluminum companies, mostly the foundry side of the industry, will implement more and more scrap in order to have more green aluminum coming out of the process, right?
exactly.
So you
The
can
decarbonization goes. LIBS is an ideal tool for the decarbonization processes of this
exactly.
sort of
That's my next point. From
industries.
the sustainable point of view, how LIBS is, let's say, putting a really good effort to make the industry go in that direction. So how? Because I understand it pretty well, but I want the people that is listening to this episode to understand how your technology can improve not just the way that you sort and segregate everything, but also how, from the sustainable point of view, this technology is something that we really need to implement into the industry.
The first point, that recycling aluminum helps saving energy. It's the number of 95% energy
Oh yeah.
saving compared to the primary aluminum. If we are talking about aluminum recycling, this number is always shown and mentioned, because it's really a huge energy saving compared to produce primary aluminum.
Right.
So that is one of the key points. But I always say, okay, we recycle aluminum, but how to recycle is really an important point. So there are technology already from the past, traditional technology based on physical density, for example, when lighter elements and lighter fractions could be separated, but it's not enough to produce even higher added value to the aluminum scrap. So you need very precise sorting, and you need to make what we already discussed, ready to melt fractions. And through this, you have the foundries to save energy. And that's one part. It's not entire definition of the green aluminum, but it helps to produce green aluminum on a certain way.
Right. No, I'm totally agree. Now, I always have this or I always had this idea that we are making a mistake here in talking about the industry, that we are comparing the secondary aluminum industry against the primary one, and that put the secondary aluminum industry in a very good position from the energy consumption point of view, because for 1 ton of aluminum that you are processing into the primary sector, you are creating around 16, 20 tons of CO2 emission. In the secondary side, it's totally the opposite. So maybe it's 1 by 1, right? It's a really huge gap that we have in between. But saying that, what I believe that we need to understand is this technology that your technology, Austin AI, LIBS technology is bringing to the table is that we can start comparing the secondary industry against the secondary industry a few years ago. So we can really improve the industry that we want to improve. And we need to stop comparing the secondary industry against the primary, because they are totally separate, different.
It's
So
absolutely different one.
it's totally different. So what we need to understand is we can really low down our CO2 emissions, rise up our efficiency, and create more circular economy and closed loop systems. We understand, for example, something that you just said, that is ready to melt scrap out of the scrap. Now, how you will characterize, or what are those characteristics that will have this scrap that is ready to melt against the other scrap that is not ready? What is the difference?
So
tricky question, huh?
when you have a mixed when you have a mixed scrap aluminum and you are not sorting that, or you just sort by handheld devices, and of course I know that the people have been involved in the scrap sorting for ages. They have a very good experience and they are talented by eyes. Like hand sorting, I can already make difference between wrought and cast, but I would not make precise difference between 6063 or 6082, for example. And that can only be done by the LIBS sensor sorters. In the previous time, or still today, who are not using the high throughput LIBS sorters, which is the very last module of the entire sorting process line. So there are pieces and others if we start from Zorba, but at the very end where you have the light fractions, so you need the LIBS to make very specific sorting by alloy type. If you just enter these light metal fractions to the furnaces, for example, you have to melt it, of course, first and make testing and then blend with additional alloying components, or at primary if one of the component is higher. So to achieve the specific alloy composition what you want to produce, you need much more time and you need this blending process. And that is what we can avoid with LIBS sensor sorters. So if you already know what you want to get out from your smelters and what billet you want to produce, so you can set this composition into our sorter, and the fraction what you get at the end, it will be directly there. So we have users who lines the extracted belts or the extracted fractions directly to the without any additional testing. And let's say one of the example is the low magnesium. If they set 0.3% magnesium, they direct this line into the furnace and no need to add so many chlorine, for example. So they already had the low magnesium component alloys. That is one application.
Right. So
We
hold
also
on a
have
second.
very
Hold on a second, because what you just said is very. So you just said that if I'm a foundry guy and I understand very well what is the composition that I need on my final product, I can just send that composition into your system. So your system will be ready to separate as much as they can from the source to give me ready to melt material in order for me to not use too many alloying elements or P1020 that is the primary ingots that I am getting,
Exactly.
to rise up whatever element. And also this type of approach is allowing me to not use chlorine or fluxes or something in order to reduce magnesium or whatever. So, wow,
Absolutely.
that's crazy. It is crazy because actually it's giving to the foundry industry the opportunity to really use aluminum scrap without getting into all these different activities that we need to get into in order to have a final product with a really good quality.
Absolutely, that is our
Wow.
goal. And another application, it's only about cast aluminum, but they set a very low copper, 0.1% copper
Right.
content. And they are also extract from that sort of alloys composition, and they also line it directly to the furnace. So I believe that we have this foundry industry on a high scale,
Wow.
saving a lot. And so
Energy,
that's our
money,
goal.
time. Wow, it's crazy because you are closing the
Especially,
loop.
yeah, we try to do even better and
Yeah.
better. So,
Let me ask you
of
something.
course,
What happens when the scrap is a little bit wet or has some oil content? Because at the end, I mean, this sounds beautiful, but not everything is like that, right? We will have obviously more contaminants coming on the scrap that can be like painted scrap that we need to put into the lacquering system, or can be like plastic involved, like thin films, or also can have some oil or water. How the system is reacting to these different type of compounds?
so what we definitely can state that we have a very powerful laser in our LIBS module, and it goes through paints. In paints, it's no interferences,
Okay.
and also voice. We are not using an additional cleaning laser. Some of the competitors are working with two-step laser. First is cleaning, and the other is the analytical laser. We only are using one laser, which is very powerful, so goes through the pen and also voice, for example.
Right.
On the other hand, oil is not a problem. So we burn it somehow and also going through. And if the material is wet, we had one user in England when the material can be really bad. And through the feeding process, for example, it dries a little bit. And when it gets to the laser, we have no issues with any of the wet surfaces. So we are not yet afraid, or not afraid of that sort of
Yeah, it's not an issue. It's not an issue
coating.
for the system to separate the material, no matter
If
how.
there are some coatings or
Right.
contaminants or whatever.
Is the system able, because I think this is the next step, as far as I understand, and as far as I want to, because my idea is to also help the industry go in the direction that we want, to go, that is completely green and sustainable. And for me, sustainable
Yeah.
is not just reduce the CO2 emission, is make your company more profitable, is be more efficient, is, waste less energy, and have less people working into the facility, because you have more automation, you are having closed loop systems and circular economy, so you can put the people to do something else that is better for the company, instead of just working in a super hot condition environment. Now, saying that, I really think that between your system and the foundry, we need to define what is ready to melt and what is not. For me, what is ready to melt is a completely clean, dry material, right? When we have some sort of oil or water, definitely we need to go into a different process to take it out, in order to not create some oxides and dross and all these different type of material that is coming out of the foundry. Is your system, or can your system being able to separate the material that contains some oil in some point, to have, let's say, a bin and say, hey, you need to put this material into the lacquering system, or is not?
No. We just usually say that what we feed into our lip sorters does not need to be cleaned on the surface,
Right.
because our laser line etches through these contaminants. So if the furnaces need fully cleaned surface material, so our LIBS is not doing that. So then the original feed has to be like already claimed.
Right. Let's talk about the cost. The cost of not the cost of your system, the cost of production cost. But I think it's very, very low. So I think I saw like it's 2 cents per pound or something like that.
Yeah,
How?
that is what we calculated. It's very, very low. But if anyone is interested in our technology, we can set an Excel table about the return on investment, for example. So what material is fed, what sortation process is done, how much they bought, so they can make it themselves how profitable their process. Because what we saw, the return on investment on our system is usually within 3 years. So it's usually calculated a little bit higher than 8 hours a day. So it gets it 2 shifts a day. But of course, it's everybody's own business, what sort of material they buy, how much they argue for that. So it's their own. But what I saw in some of the users already, that they could buy cheaper and more different alloys or more different mixed scrap, because they can extract very high purity ones. So I mean by composition. So this is what we already saw, and it's not my business, of course, to calculate the profit. But what I saw, it's usually within 3 years. Absolutely, the investment. Even if it's, of course, every LIBS sorter is a little bit high by investment, but the return is really favorable.
Yeah, I think 3 years is a really good payback time for such a system that will allow you to be more flexible, more profitable, more efficient. Definitely is a really good advantage.
That's a good word I usually use. It's flexibility. So we provide really, really high flexibility to our customers using the LIBS.
Nice. Now, I want just to let the people that will watching this episode that we will add all the videos and all the different technology setup, and we will share all the links and everything for you guys to go and check the web page, the YouTube videos. But also what I will do is during your description of the system that you said that the lasers is positioning, we will have the full video so the people will see everything and how the system works, because it's a beautiful way that the system works. I already watched the video and it's beautiful. Now, to wrap up this episode, Judith, what is the future? What are the trends that we can expect from Austin AI Europe company? What is the future of this technology in the industry? What we can expect?
What we believe that, as you also noticed, that more and more interest from the aluminum industrial players are turned to the LIBS sorting. It's not just recycling, it's a specific recycling. And of course, we would like to fulfill everybody's need. More and more achievements are right now on lowering this already low detection limits of our system, because, for example, copper and zinc, the heaviest alloying components in the aluminum alloys, are requested in less and less concentration ranges. So that is one of our goals, to have higher or better performance on these elements. And also we would like to increase a little bit of our throughput options, maybe adding more channels, more lanes to our 6-lane system. Oh, there are. And maybe we have to mention that we also have a LIBS model for the full wheel cars analysis. So those who are dealing with that sort of scrap, they do not always have to shred the full wheel cars. We have a system which analyzing the full wheel cars, so they can save some time, energy again with the shredding process as well. So we would like to develop further new models, still based on the LIBS, because it's a relatively new technology. so no other technology yet is anticipating us or this, but this is our future plan.
Right. And for those that wants to test your technology, because I know you have like a test facility that test scrap, different type of scrap from aluminum side. So
Mhm.
where these people can find you and how the people can contact you in order to or request some information about your technology or making some or running some tests.
So we have a test facility in Budapest. Sorry, my lights a little. So we have a test facility in Budapest. Everybody is welcome. So everybody could contact us either through our website or my LinkedIn profile, for example, so or the Austin AI Europe LinkedIn profile. So we are always online with this sort of requirements anytime, and we are really happy to make a test for their material or have a first introductory call directly with them to see and learn their requirements and what they would like to use their LIBS for. So it's really a very nice meeting with everybody from this sort of industry and learning their requirements and their routine in the aluminum recycling or also in magnesium recycling. Already we had very good achievement to specify different magnesium alloys in the mix or sort it out from any type of mixed metals.
Right. So before we, what are those things that you are, let's say, impacting with your technology? It's not just aluminum. I can see that, or what else? Copper, maybe brass, risk. Which?
For first, I want to focus on the aluminum industry, and already as mentioned, the magnesium industry could be, because in the copper, who are mostly dealing with the heavy elements or the heavy metals industry. Sorry.
Right.
So those are good with XRF, I believe. So LIBS is a newcomer in this recycling industry. But if they are starting from Zorba and they want to do anything and make added values on any fraction, so the light metal fractions to be sorted further with the LIBS technology.
Okay, so right now aluminum is the focus, and people from the aluminum industry that are out there and is looking for some such a system that can help you to be more flexible, that be more accurate on your segregation and sorting process. And if you are looking for some ready-to-melt scrap, so you already know that Austin AI is the company that can provide this type of technology. You can have, and you will see on the description, the link of the website, YouTube link, and I will also add your profile on LinkedIn so people can just reach out to you. And well, what can I say? I really appreciate your time. It was amazing to understand how this technology works. I think it's the future of the aluminum recycling industry for sure. And I think this technology and this approach is helping to merge together the scrap jars and the foundry industry to have a very, very good relationship in order to build this green aluminum trend that we want to build for the next 10. So Judith, thank you so much for your time. I really appreciate it. Anything else that you want to share with us before we leave?
No, I'm just want to thank you for your time and the opportunity to be your guest in your special podcast, and wishing you any further good luck for the new year, and also for your listener more and more involved in aluminum industry and learning more and more about the technologies. Thank you very much so much.
Thank you so much. Happy New Year, and I hope you have a great 2025.
Dirty Scrap Podcast.